So the last skill we need to review before we can dive into trigonometry is SOHCAHTOA. So how do we calculate sides and angles with right angle triangles? So just like Pythagoras' theorem, SOHCAHTOA only works with a right angle triangle. You can't do it with a wonky angled triangle. How it works is that you pick an angle. So let's say this is the angle you're kind of chilling at. So this is like you relative here at this angle. Then the side that is opposite you, we call the opposite. So this is the opposite side. The side that is right beside you, so the opposite, there's only one side opposite you. But there's two sides that are right beside you, right? There's this one and there's this one. The one that is right beside you, but also attached to the right angle, that one's the adjacent. And then the last side here, this side is the one that's across from the right angle itself. That's going to be the hypotenuse. So opposite is across from you, adjacent right beside you, hypotenuse across from the right angle. So let's say your angle was up here. Well, then your hypotenuse is still the one across from the right angle. Your opposite, that though now, is going to be down here, right? Because that's the thing that's across from where you're chilling at this angle here. And the adjacent is going to be the side right beside you, which is not the hypotenuse, the other one, which is this one. So that's the side right beside you, which is also connected to the right angle itself. Okay, using that, you can write down the three primary trig ratios, which is what SOHCAHTOA actually represents. So the SOH part is the sine trig ratio. That's the sine of your angle where you are chilling on your triangle is equal to the opposite side divided by the hypotenuse. Cos of your angle, so see how you've got like S is for sine, O is for opposite, H is for hypotenuse. So sine of your angle is opposite over hypotenuse. So the CA means that cos of your angle will be the adjacent, so the A stands for there, divided by the hypotenuse, that's what the H stands for. And the last primary trig ratio, the TOA, is that tan of the angle where you're hanging out on your triangle is equal to the opposite side divided by the adjacent. All right, let's try this with a bunch of examples. So let's say you know this angle in here. So you know that's 27 degrees. This you can tell clearly is the right angle. So the 14 must be the hypotenuse. And the x here is adjacent to the 27 degrees, right? So that's the adjacent side. All right, so what you want to think about with SOHCAHTOA is if I know the hypotenuse and the adjacent, which of these three primary trig ratios should I use? And clearly adjacent and the hypotenuse are showing up in the cos trig ratio. So I should use this one. Cos of 27 degrees will be the adjacent divided by the hypotenuse. So let's fill in what those actually are. So cos of my angle, 27 degrees. The adjacent is x here. The hypotenuse is 14. I can fill that in. And now I just need to rearrange this for x. So I'll probably want to multiply both sides by 14 to get it off the bottom. That cancels the 14 there. And I get that x is going to be 14 times cos of 27 degrees. By the way, we always write when we're multiplying cos of some angle or sine of an angle or tan of an angle by something else, like by this 14, we always write the 14 out front. You don't want to write like this is still means the same thing. But the problem with this is it's not clear if you're multiplying the 27 by 14 and then taking the cos of it, or if you're doing cos of 27 and then the 14. It's just vague mathematically, and so we never write that. So you're not going to write it like that. Put the 14 out front, like that. And then you can just type it into your calculator. Make sure your calculator is in degree mode. So you should notice, like often on most calculators it says DEG or just a little d, meaning degree mode. If you get really weird numbers, you're not in degree mode when you do this. So check that on your calculator. So x is going to be 12.47. All right, here's another example. Let's say I know this angle up here. Here's the right angle. I know this side is 11, and notice how that's opposite from my 53. So that's The 11 is the opposite. And what I'm trying to find is the thing across from the right angle, which is the hypotenuse. So x is the hypotenuse here. So looking at SOHCAHTOA, it looks like I have an opposite and a hypotenuse involved, so I'm going to need the sine ratio. Sine of your angle is going to be the opposite divided by the hypotenuse. Let's fill in what we know. So my angle is 53 degrees. The opposite is 11, and the hypotenuse is x. This one is a little bit trickier just because I'm rearranging for the denominator in a fraction. There's a few ways to do it. You can use a triangle. There's sort of like a quick shortcut. I'll show you the full mathematical way though. So what we would do is we can multiply this side by x and this side by x too. So that's going to cancel the x's there. And you'll have x times sine of 53 degrees equals 11. And then to get rid of the sine of 53 degrees, we can divide both sides by it. Divide this by sine of 53, divide this by sine of 53 as well. And that cancels out the sine 53s. And you're left with just x equals 11 divided by sine of 53 degrees. So try tossing that into your calculator. 11 divided by sine of 53. You should get that x is equal to 13.77. All right, so that's how we can solve for any side in our triangle using the SOHCAHTOA primary trig ratios. What if though you need to find an angle, something like this? You can actually use the same process, you just have to undo your sine or trig or cos function. So from where you're at, this angle that you're interested in, the 3 is opposite you, right? So this is the opposite side. The 4 is adjacent and right beside the right angle, so that's the adjacent side. So in terms of my SOHCAHTOA, looks like I'm going to be using the TOA part here, right? The opposite and the adjacent. So I'll write that ratio down. Tan of theta is the opposite divided by the adjacent. And then we'll fill in what we know. So we don't know the angle in this case, but I do know that the opposite side is 3 and the adjacent side is 4. How do you get an angle out of a tan function? Well, you have to do the inverse tan of the other side. So it looks like this. So theta is going to be the inverse tan to the minus 1 of 3 over 4. Make sure the whole fraction here is in brackets when you do this. So you're going to do 3 over 4 and then inverse tan, which is often like shift tan of that. And you can get theta out, which should be 36.87 degrees. All right, one last example. Let's say you have this angle up here is what you're looking for. You know this side is 57. You can see how that's across from the right angle, so that must be the hypotenuse. And then you also have the opposite side here, right? This is opposite the angle that you're trying to find. So writing out SOHCAHTOA. Looks like I'm going to need the sine ratio because I have an opposite and a hypotenuse involved here, so I'll write that one down. So sine of theta is the opposite divided by the hypotenuse. And then let's plug in everything we know. Sine of theta will be the opposite, which is 39, divided by the hypotenuse, which is 57. And to get an angle out of a sine function, we have to do an inverse sine. So theta will be the inverse sine, so sine to the minus 1, of the 39 over 57. So I'll do 39 divided by 57, and then shift sine is how it works on my calculator, so inverse sine of the 39 over 57, which is 43.17 degrees. And that's your angle in there.